We've been hearing about it for years. The 21st century is the era of urbanization. In almost every country around the world, people are packing their bags and moving into cities at record rates. This is a global phenomenon across the spectrum of developed and developing economies. Approximately 54% of people worldwide now live in cities, 30% more than in 1950. And projections show that urbanization, combined with the overall growth of the world's population, could add another 2.5 billion people to urban populations by 2050. For better or worse, we are increasingly becoming an urban world. Thus, it's no surprise that the demand for city housing is skyrocketing. Prices to rent or to buy are reaching for many unattainable highs. There are political motivations and many more factors that change why and how bubbles like this occur in different cities, but if we're going to build a sustainable future, we are going to have to rethink how we build and plan our cities. So you may be thinking, why aren't there more high-rise buildings? There must be reasons why we aren't building more of them.
Cities around the world use a floor space index, or ratio, to regulate the maximum amount of floor space that can be built on a given plot of land. For example, a floor space index of 1 lets builders build 1 square meter of floor space for every square meter of plot. The builders get to decide whether that means covering the entire plot with, say, a 1-story building, half the plot with a 2-story building, or 1/4 of the plot with a 4-story building, and so on. So, the higher the FSI, the more space that can be built on the same plot of land. The higher allowable FSI in cities like New York has enabled more offices and apartments to be built on the same land. Instead of sprawling outwards, Manhattan has grown up. In fact, by letting buildings grow tall, Manhattan has increased its size by almost 2 additional Manhattans. An amazing way of making more land, essentially out of thin air.
Zoning regulations like this are important to prevent brainless growth that destroy a city's character, but sometimes they are overzealous and prevent modernization altogether. San Francisco, a city notorious for skyrocketing cost of accommodation, has an average building height of just 3 stories, mostly due to similar restrictions in building heights. Washington, D.C. has some of the worst traffic in the US, and it has height restrictions blocking anything taller than its national monuments. In large cities with restrictive height regulations, you can almost be guaranteed socio-economic problems will follow. This is a problem that primarily affects young people, and those who already own their home have little interest in devaluing it by allowing high-rise developments near their home, and thus increasing supply. There are political motivations and many more factors that change why and how bubbles like this occur in different cities, but if we're going to build a sustainable future, we are going to have to rethink how we build and plan our cities. Let's next focus on minimizing the building cost of these buildings. In theory, taller buildings reduce square meter costs of floor space the higher you build, and increase the overall returnable revenue from a single plot of land. However, the cost increases as you build higher and higher. Lift systems, fire prevention measures, water supplies and pressurization, and heating and cooling systems all add to the cost of high-rises. Costs like these lead to a U-curve in regards to the cost per square meter and height, where the cost per square meter initially decreases with an increase in height, and then starts to increase after the height reaches a certain point due to the increased engineering demands. Every curve therefore has a bottom out point. This bottom out point is different in every city and varies widely even within the city. But on average, the lowest cost per square meter in Shanghai and in the Netherlands, for example, is around 8 stories. In Hong Kong, thanks to the limited land area increasing land cost, it's around 12 stories. The additional cost of engineering can be marginalized by high costs of land, making it worthwhile to build higher. Let's next focus on minimizing the building cost of these buildings. One of the primary causes of increased cost with increased construction height is the necessity of using floor space for the structurally integral building core, which keeps the building standing and houses elevators and other services. While there are many ways to design the shape of the building, certain floor plate designs end up being more desirable than others to maximize usable space. Say that the net area of the floor plate of this building is 1,400 square meters. The core of the building of this shape and size would need to be around 335 square meters. This gives a gross area of usable area of 1,065 square meters, and thus a net to gross ratio of 1.31. So a design like this is stylish, but when you analyze the space efficiency, it's not great for maximizing floor space. A building like this seems like it might have a bit more usable space, but the building core is still taking quite a bit of space compared to the livable floor area. This design's net to gross ratio is around 1.26. And a building with this shape may not be as exciting, but its core area is minimized compared to the usable space. Its net to gross ratio is only 1.14, which is about as good as it gets and is exactly the floor plan of 432 Park Avenue. While variety and expression in building design are important, these elements invariably add cost and require careful design consideration. When affordability is an issue, simpler designs are better. Wall-to-floor ratio is also a critical measure of cost efficiency. It expresses the perimeter length of the wall that has to be constructed for every unit of floor area, so from a cost perspective, the lower the ratio the better. Using simple geometry, we can see that a 3x3 square has a total perimeter of 12 meters. This would have a wall-to-floor ratio of 0.33. A cross shape with the same area of 9 square meters has a perimeter of 20 meters. This would have a wall-to-floor ratio of 0.45. When constructing buildings, this simple principle is the same. The more perimeter wall needed per floor area, the more expensive things get. A comparison of Asian and London towers provides an interesting contrast on approaches to wall-to-floor ratios. Tall Asian buildings score between 0.3 and 0.35, while London buildings score between 0.35 and 0.6, with the majority above 0.45. This is because the Asian buildings have larger, more regular floor plates with centrally located cores. So the design of our tower has huge effects on our cost, but so does construction techniques. Traditionally, towers are built using repeating floor design with molds called formwork being used to cast the concrete structure. Despite this essentially being an automated assembly line, it can still be labor intensive and slow and is exposed to variabilities of site and weather conditions. Prefabrication and off-site construction is increasingly becoming an appealing option. This can offer high-precision solutions created in factory conditions and often reduce on-site delays and help progress construction even in a market with a skills shortage. An extreme example of this idea of prefabrication is being used in China, where a company called Broad Sustainable Building built a 30-story building in 15 days for a cost of just $1,000 per square meter, and later built another 57-story building in 19 days. The building pieces are fabricated in sections at 2 factories in Hunan. From there, the modules, complete with pre-installed ducts and plumbing for electricity, water and other infrastructure, are shipped to the site and assembled like Legos or flat-pack IKEA furniture. The company is in the process of franchising this technology to partners in India, Brazil and Russia. What it's selling is the world's first standardized skyscraper. One of the primary cost drivers for skyscrapers are the labor costs for specialized workers. By outsourcing much of the construction work to safer, controllable environments like this, we can reduce the costs. Building higher facilitates cost-effective public transport, reduces commute times and creates a more livable city, because their height enables a huge number of people to work and live on a small piece of land. That is something our world is going to need going forward as our populations continue to grow.